Well. It's you again. Welcome back. We're still here, trying to kick it. Now we're looking at configurations. Yes, like, subscribe so you miss nothing. You would already know. If you're subscribing, when this drops, you'll be the first to know. All right, let's go on and do what is next. We are going to do what is called a summing amplifier. Let's look at a basic. We've looked at this before. Let's look at, I don't like it. Let's go and look at our inverting amplifier. We have obviously that's only, remember, this is not our inverting amplifier yet. It's our inverting amplifier if the input is there and the ground is here. If we swap ground and input, it becomes our non-inverting amplifier. Now what do we then do? Say, okay, we remember that because this is going to be driven to virtual ground, because this is grounded, this is going to be sunk to ground. Let me rather do this. Let me rather say it is going to be sunk to ground. Okay, that means it's sunk to ground. That is going to be virtual, our sinking concept again. Now we've got R1 here, or R in, R1. We've got RF. What if now we said, okay, let's rather have this as V1 and not V in. Why? Because we are going to add a second resistor, and let's call that R2. What happens here is this V2. What happens here is this. Obviously, these points are all ground. Now, obviously, this V2 here is going to have a current there because V1 is between R1 and ground. V2 is between R2, R1 and ground. This one is between R2 and ground. This is V2 and ground. Which ground? Virtual ground. All right, so now you've got a current there, I2 and I1 from V1. All right, I'd like it to be clear. I1 and I2. So what happens here is that since these two currents are both going to be rejected by this massive input impedance to the op-amp, so they are all going to be forced to go that way. What is this here? It's going to be I1 plus I2. Okay, if we had a third one, we are also going to have V3 there, because this will be V3 and this input resistance of R3, that's going to be R3. So again, it is wired to the virtual ground, so a current is going to develop there, which is going to be rejected by the op-amp and sent that way. So this is going to be plus, I'm running out of space, I made it a little bit too. I1 plus I2 plus I3. The three currents, this here being I3. And so on and so forth. We could have 5, we could have more. Alright. So what are we saying here? We are saying basically our V out is simply going to be, we know that what is this current here? What is this current there? Alright, let's first say our V out, to make it clear, it's going to be, obviously it's an inverting, and then it's going to be RF by the currents. Remember alright, let me first make this clear. I think I'm jumping the gun here. Let me make assumptions. VF is going to be V through RF. Remember, our V out is measured between ground, which is the same as virtual ground. So this is virtual ground and ground are the same. The potential is 0. So our V out is measured between that and ground, which is the same as that and virtual ground. So our voltage out is the voltage through RF. All right, let's make that clear. Once that is made clear, it means therefore our part is a negative. Why? Because it's an inverting amplifier, and therefore we know that our voltage is normally, according to Ohm's law, is going to be current times what? Current times resistance. So which is our current there, according to Kirchhoff, is the sum of those. That is our current through the RF times the resistance RF. Right. Now we remember, how do we get this from Ohm's law? Is V over R. So this one here is going to be V1 over R1 plus that one there is V2 over R2. That one there is V3 over R3. And therefore times RF. Okay, so now basically what you have here is a scenario where you have these voltages here. If I want now, I can say minus RF over R1 by V1 plus RF over R2 by V2 plus RF over R3 by V3. Okay, so therefore this is literally our what? Our output formula for the voltage here. All right, so I don't know if this is difficult. So this is basically our summing amplifier. All right, this is our summing amplifier. So we could have a fourth one, V4. I want to have V4 for a specific reason. I want to have V4 and I would have I4. Therefore it means here I would have to say plus I4. Okay, my formula would have to have I4 there. All right, that would have to be, so it would have to be, if I had 4 of them, then I would have to add plus I4 in there. I would have to have plus I4 there. Let me not do that. Let me rather say, if I had that R4, all it means that I would have obviously a fourth supply there, V4, R4, and ground. So what it means here is I could basically just factor in what to get our thing there. Our current there would be I4, and we'll have V4 of R4. All right, for that these currents here, I1, I2, I3, and if we're the fourth one, I4. I'll come back to a scenario with 4 of them, but for now let's just stick to the 3 resistors here. And I would like the next concept I'm going to entertain is going to really need people to understand. I'm going to come back to what to the summing amplifier, but a specific case that I really want people to understand for other concepts for digital electronics. When we come and talk of a guy called the what? Digital to analog circuits, you will understand why I want the fourth one there, but I'll come back to that. It's just basically the understanding of a what? Of a summing amplifier. I hope that was fun. I hope you liked. I hope you subscribe for the next session so you don't miss it. Till then, I hope this was fun.